Hello, my name is Marshall Nambiar, and I worked on a project titled Determining the Most Effective Design and Materials for Realistic Myo-Controlled 3D Printed Prosthetic Arms. Over the summer, I was interviewed for a position at the FDA in the Additive Manufacturing of Medical Products 3D Printing Laboratory. I was given an idea about 3D printing prosthetic arms, and after completing basic background research, found out that there is very little known on the reliability and effectiveness of 3D printed prosthetics. I was inspired to do a project in biomedicine because of the large value that it holds to the world. Currently, there are over 11 million people in need of prosthetics around the world. Prosthetics are not cheap and can cost over $50,000 for a decent design. Myoelectric models, which work by gathering EMG data from muscles and mimicking movement on the hand, cost over $100,000. Maintaining prosthetics are also extremely expensive. We need newer and more efficient methods to give amputees realistic prosthetics that can change their lives. The traditional metal prosthetic pathway requires a lot of money, and the majority of people cannot pay this price. On the other hand, 3D printing offers a novel and innovative solution to the problem of expensive prosthetics. 3D printing is a growing technology that started near the 1980s. With the ability to print any 3D surface, 3D printing allows users to create intricate shapes and designs to make prosthetics fit the ergonomics of any user's hands. Here is an arm that I developed. There are three major parts to this prosthetic arm. The first part is called the gauntlet. This part connects to the upper forearm. It helps keep the arm sturdy and in place when being used. It also connects the prosthetic to the user's arm. The next part of the prosthetic is called the wrist extension area. This part houses all of the electronics and expands the entirety of the forearm. It also houses the string and the servos, which are connected and used to tension the hand. The last part of the prosthetic arm is the hand itself. This hand was created in two main parts. All of the phalanges and fingers were printed with the NinjaFlex, a soft material which is used to emulate the flexibility of the fingers. ABS plastic was used to print the rest of the parts. This is the same plastic that is used to create Legos. It is very sturdy. Arms were programmed with the Arduino software and used the Myo band to determine the EMG values. The arms that we used had only one servo, and based on a threshold value, could open or close. We tested two main designs for the hand. One design had the thumb out at a 90-degree angle, while the other design had the thumb up. The box and blocks test was used for testing to determine a value for how much dexterity the arms had. In this test, the user had 60 seconds to move as many blocks over a glass partition and onto the other side. A questionnaire was also used to gather data qualitatively and to determine which designs were the most comfortable and sturdy. Overall, we found out that the design with the 90-degree thumb was the most effective. We want to continue testing and work with more servos for designs and for more degrees of freedom. This project helped me explore the field of biomedical devices and medicine.